Now all we need is right here in front of us. In front of us. So can we just slow Oh no, that is what they all say when they see me falling to mine. Oh, think it's empty again. Let it fill me up before I go. Cause I'm up in the feeling it, touch me and being to see what I see and make it difficult. Messing around with it, mix it up, go with it, fuck with it, flow with it, let it all go. Oh Lord, think you know what I'm like. But you don't fall, you lose control. Bittersweet melody when I dance on your fly. Cause I know what you don't. It is me you adore.
Hey everybody, happy Thursday. Hope you're doing well. Let's see. Yeah, there we are. Oh man, the lighting's a little off again, sorry. I'm here, sort of, in front of the window. Hey, alrighty. So it is 3:30 on October 8th. Project 0 is officially due, as we're about to go over the solution here. Let me just refresh here real quick. Alright, I got 8. Remember, after you commit it to GitHub, I still need you to add it to Canvas for me. You gotta go to Canvas and submit it, the URL to your Python file. Right, that's what I need. So I need the URL to your Python file. Right, so I can still take that for another little bit here, and then we can go from there. So hopefully this one went well for you. I was taking a look at our schedule here upcoming, and I didn't actually put the projects in here because it's a little bit flexible. So we finished up Project 0 this week, and we're gonna have another project due in 2 more weeks. We got the midterm in the middle there on the 19th. I don't want that one to be stressful. It should be relatively low stakes, right? It's only 20%. I guess that's a lot for an exam, I'm sorry. But we'll have lots of practice for that. We do our midterm review next week, and we'll get our, so this was, the first project was due, the second project will be due, we'll get another project, the third project will be due, and then the fourth project will be due, and then we'll get our final project. So that should get you 4 individual projects, right, that make up this 25% of your overall score here. And then we'll have the final project making up another 25%. That midterm exam, the quizzes you've been doing all along. Again, I'm sorry, I think I forgot to post some. So they're out there now. And I'll post the functions quiz later today. And you got at least a week for those to do them. I haven't gone over any of the answers yet. So if you're still interested in taking it, I can still take it from you. Usually I don't take stuff late, but because we haven't gone over the answers yet, I can be a little flexible there. The labs that we do every Monday, hopefully that's going well for you guys. You want to try and get to the habit of doing it the Monday it's assigned, not the Monday it's due, because then you're behind another week. And the idea is I talk about something for Tuesday, Thursday, and we practice it on Monday in lab, and that stuff is going to show up in your projects. So if you're not comfortable with it because you haven't been practicing it in the labs, we're going to have some trouble. And then 10% for following along in the Zybook. Let me take a look here at how's it going with that. Let's see, because we've got 13 people subscribed to the Zybook, and no one has done anything in Chapter 6, best I can tell. And only 34% of Chapter 5 has been done. That's like, out of the 13 of you, 35% of you have done it, or it's hard to tell sometimes exactly what that means for those ones. And looks like the labs, a couple of people have gotten the labs done. How are the Zy labs going, by the way? Please let me know if you get stuck on those. Again, they're for your practice. I know they're very particular down to the individual space and new lines, so they can be a little frustrating, but it's definitely good practice, and it's good attention to the detail for working on those and making sure they come out as we'd expect. But how are you guys feeling so far? Is anybody even here live? I see a couple people in chat out of the 14 or 13 of us, of you guys. Yeah, for sure. Definitely focus on the project because it has the due date. You can come back to the labs, but if you get too far behind on those, it's going to be a really crappy last week when you're trying to study for final exams for other classes, final projects, and you have all those labs hanging over your head. You know, again, it is only 10% of your grade, so if you choose not to complete the Zybook, that's totally up to you. You can still pass the class without doing it. Again, but if you're the kind of person who wants to get particular letter grades here for GPA reasons, yeah, I think you should have some of those channel points there, Ryan, you can redeem for a dad joke, or I guess I can give you a freebie one too if you want. So my son is really into books. My 13-year-old, he's 13 now, that's right. It's weird I have two teenagers, but he's 13 now, and he's super into reading books. He's read tons of the fantasy and sci-fi books. He's gone through the Harry Potter series, of course. He's gone through Narnia. He started into Dragonlance. He's read The Lord of the Rings, The Hobbit. I'm trying to think of some of the other big ones. The Bulgarian series, sounds a little bit older by David Eddings. But the other day he was just sitting there, and he just finished up a book, and he said, "Dad," and you know we're chatting here, and he goes to put his book down because we're gonna go do something. He says, "Can I get a bookmark?" And I just start crying because you know he's 13 and he still doesn't know my name is Eric. I don't know why he keeps calling me Mark. Is that one okay there, Ryan? All right, so we're going to talk about how I go about solving Project Zero. Again, it's just one way. It is not the only way to solve it for sure. Programming is very, very, very much an art. I'd argue more art than it is science, and not to diminish the science part of things of being precise and optimizing your solutions and all that good stuff that goes into it. But the art of programming is how do I take a problem and break it down into smaller steps and smaller steps and smaller steps and smaller steps. And that's sort of what we're doing here with functions. Again, we didn't need to have functions, but we could have used functions, right? They kind of help us organize, even if we're not reducing the redundant code, or even if we're not making our code reusable here with a function, we at least have broken it down into smaller and smaller and smaller pieces to help make a little more sense, at least, right? So let's see. I think I've got... I should really go check this out here. Let's open up my other project. Come on. Of course, it never starts in the same directory. That's fine. That's fine. In my documents, in GitHub, 1501. What do we have here? Yeah, Project Zero stub. Why don't we start with our Project Zero stub that we did last time? Was the joke so bad, Ryan? It just knocked you off Twitch chat? I'm sorry. I miss hearing all the groans in person when we have terrible jokes really hit home. Let's see. So we kind of laid it out and said, okay, this is kind of the guts of what has to happen. Doing this functional decomposition. Again, throw that term out at your next family gathering just to see what kind of looks you get. It's such a phenomenal term. All right. So we said, all right, as long as we want to play again, we're going to spend $1 on a ticket. We'll figure out the winning ticket. We'll ask the player if they want to pick or manual. And again, that's just going to return easy or not. That's kind of a silly one. But sure, you know, that's something we can do to put into its own little piece. That's one problem we can solve. Otherwise, we get a random number, and then we'll get the total one, which is the get total winnings. And get total winnings said, okay, given the winning ticket and a user ticket, let me see if you got a straight win or if you got a one-off win. And we'll just add the sum of those together. Right? For now, we didn't actually do anything. We just added 0, right? Which is a fine approximation because most of the time you lose. I mean, that's how the lotto works, right? And we just keep on going until they don't want to play again anymore. And I think we've kind of modeled that off of the rubric here, right? So we need to figure out how we can generate random numbers. We can pick an easy ticket or their own numbers. If they're doing their own numbers, we need to make sure we're validating. So maybe we get a little bit more here. So if we're doing user pick numbers, right, there's a little bit more to it that has to happen here. We need to do some sort of validation, right? And whether or not we want all of that to be in this, or if we want to break out another function, that's perfectly fine, right? We've got choices for what we're doing here. Where to go? And then we're going to figure out the straight win, the one-off win, tracking that total spent, net won, net loss, which is really total spent and total won, and you calculate the net loss, right? We're going to fill in the blanks here, printing what your net loss was, which is your spent, I'm sorry, your won minus your spent. Right? How much you won minus how much you spent is your net loss. And if it's not a net loss, you're doing something wrong. I mean, it is possible that the first time you run it, you win, of course. But like, the more often you play, the more you're going to lose, guaranteed. So that's the next fun thing we'll do, is instead of like asking them if they want to play again, we'll just say, hey, how many times do you want to play? And we'll just generate random numbers, say 50,000 times, and say, okay, if you were to play every day or 5 times a day for 1,000 days, or whatever, right? And we'll figure out some sort of number here. We can show people how much money they lose, and we can go from there. The lottery is terrible. I have strong feelings about it, but you know, maybe we can educate some people and show them that it's a waste of money for them to play, and it is not a retirement plan for people. I don't know, it just makes me sad, just really sad, because more often than not, the people who can't afford to play are the ones who play. Alright, so let's give it a shot. So we've got our stub here, let's go and finish it out. So where do you want to go first? How about ask player for easy pick or manual? That's a nice easy one, right? So we're going to say we can just return an input of, do you want an easy pick or to pick your own numbers? And we'll just try and hopefully give them a prompt here like easy/own or pick, I don't know. And hopefully they'll type in easy or they'll type in pick. Right? And maybe we want to actually flip that around so that the default is the easy pick, but it doesn't matter too much, right? That one should be done. That's all it is, right? Just again, we didn't really gain anything by making this be a function, aside from we separated this out and now we have a nice name for what's happening. That's all it is. Okay, ask if they want to play again. Oh, we even did that one, right? There was nothing about it, right? Yes or no, we just returned it. Done. I guess I even solved that one for you. How about get random numbers? That's an easy one, right? So we need to import random. And we need a bunch of random numbers, right? So it's random.randint, and this is inclusive, so it's 0 to 9 inclusive. We'll give you a random number between 0 and 9, and we just do that 4 times. 2, 3, and 4. Right? You're welcome to save them separately if you want. Why does it not like that? Oh, I did have white space. Okay. You could like do them all first and like have number 1, number 2, number 3, number 4. You could append them all to a list. Any way you wanted to do it is perfectly fine. This will just get 4 random numbers. Okay, and we can even test that now, right? Because we want to write a little bit of code and test it, write a little bit of code and test it, write a little bit of code and test it. So I'm going to put a breakpoint in here, and instead of run, I'm going to hit debug, and we're going to see if we can get some winning results. Because right now we're not really printing anything out. So we can either print, which is like the poor man's debugger, or we could actually watch it in debug mode. So now we have a winning ticket. It's 3, 6, 7, 9. Awesome, we're done. And even like we'll show you right in the editor window, which is fantastic. You don't always have to go to this variables window. Super handy. And then we're going to see if we can get prompted here. We got to go over to the console side. Let's do an easy pick because that will give me more random numbers, right? Back over to the debugger, step. Now my user ticket. Uh-oh, all zeros. Oh, I've got this backwards, right? This is wrong. User pick numbers is, if they said easy, is backwards, right? That should be random numbers, right? So good, we found a bug. We already found a bug. So let me flip those around. Copy paste, right? So if it's easy pick, they get random numbers, else they get to pick their own numbers, right? You guys should have pointed that out earlier. You get no bonus points if you didn't catch that mistake last time. Okay, so we're good there. We get the random numbers. Now let's figure out how we get to pick our own numbers. Right? So, and we wanted to do this sort of thing inside of a validation loop, because I want to make sure you're only entering 0 to 9. So, a couple ways of doing it. Hey, Uncle Bill, thanks for joining us. We're doing a little lotto simulator here for our first project. So, to ask the user to pick numbers, right, let's just do 1 to start. Maybe we'll add another function, right? Nothing's going to hurt to add another function. So, get single number. Okay, and in here, we're going to do an int of an input. So we'll have a number equals an int of an input for a number 0 to 9. Okay, and then as long as that number is less than 0, or, I'm sorry, 0 is less than the number, or the number is well, the number is less than 0, or the number is greater than 9, we want to stay inside the loop. Right? And there's lots of different ways to write these logical operators here. We want to say if you're either less than 0 or you're greater than 9, you're invalid. Or we could have what's the valid range and say not valid. So maybe that's even cleaner. Right? So that's one option. I'll say while 0 is less than or equal to number is less than or equal to 9, and we want all of that as a not, right? Because that's the valid range, and we want, I'm sorry, not that. You could do it this way if you prefer. So this is valid, and we're saying, well, not valid, right? Perfectly fine there. Either way you prefer, both will do the exact same thing for us. Doesn't matter. If that's not valid, we just need to ask them again. Try again, enter number 0 to 9. Right? Eventually that number will fall within this range, and this will be true. Not true is false, and a while false will stop the while loop. Right? Then when we're done, we can return the number. So it's possible this loop never runs. Right? A while loop doesn't have to run at all. It's 0 or more times. So if the first number they give us is valid, we're off to the races. Right, so this is, we were saying while number is invalid on either side. And this loop here is really a while not valid. Right? That makes sense, what we were doing with those ones? So it can get a little confusing, so we got to practice. We'll return the number, okay? So we're pretty good there, right? So that will get us some numbers. So then what we can do is we can just do this 4 times. Right? 1, 2, 3, 4. That might look a little funny, but like we don't need any intermediate steps. We don't need to save it off as a list and append all these things. We don't need to create our own tuple. We can just stick them right in the return statement. And maybe that's a little funny, but it's going to work, right? So it'll pick a single number, and it'll pick the next single number, it'll pick the next single number, it'll pick the next single number, and we're good. We'll give them something. Should we try it? Definitely we want to try it, right? Any code that's worth writing is worth testing. Try it out. Oops, I needed to debug that. Let's make sure we get our breakpoint in here. So let's put a breakpoint in user pick numbers. That's perfectly fine to add them to lists. There's nothing wrong with doing it that way. Yeah, it's not going to hurt anything to be a list and then you return the list. So the one technical downside of doing it that way, remember when you add them to a list and you pass the list, they're going to be able to go modify your list. But again, it's only inside of our code, so it doesn't really matter too much there. All right, so let's do a pick our own numbers here. And great, now we're in our debug. We got to this line 56 here, and now we want to make sure we step into to go into our function. Yeah, it's okay to add them to lists. It's definitely not wrong at all. This is just a shortcut, right? I'm just being lazy here doing a shortcut. So let's make sure I can get a single number, right? So we're now here at line 20. Yeah, for sure. As long as it works, that's all that matters. And you can see here in our stack here, we were at line 56. Now we jump to line 20. We're going to step in again, and now we're at line 8. So when line 8 is done, we're going to come back here to 20. Or when this function call is done, we're going to come back here to 20. And when 20 is done, we're going to come back here to 56. Remember, Python tracks where we are, so we can kind of walk through that in the debugger. So I'm going to hit this resume here, because I need to enter a bunch of numbers. And we got to enter number 0 through 9. So let's try like 10. Oh, I get my try again message. And how about 1? That was good. 2, that was good. 3, 4, that was good. All right, seemed to have worked. I didn't actually see if I won any money or not, but it looked like it gave me some numbers. Okay, we all right so far? So we're writing some code and we're testing. We're writing some code and we're testing it. That's kind of the beauty of having all these method stubs, right? Is that they will at least sort of work and we can kind of see some results as we go. All right, should we do the straight win first? Because that's probably the easiest one, right? Check for a straight win. Right? Let's try it. Let's see if winning ticket is equal to the user ticket. Return, what was that, $1,000 winner? Else return 0. And really this else here is redundant, because remember, a return will stop your function. The code stops running. Totally done, hard stop. So the else here is redundant, because if this was true, it's going to stop. We're not going to do anything else. So usually you just ignore these here because it's redundant. Redundant. There we go. So if it didn't return, we're going to return 0. That make sense? So we're going to pause here. We're going to put a breakpoint in so I can cheat, okay? Because I'm going to see what the winning numbers are, and then I'm going to pick those winning numbers. Because I don't want to wait for random, right? And hopefully you did this sort of thing where you pause to make sure that we're getting the right values. So let's step one time. All right, so 3395. Okay, let's continue on. I can take this breakpoint off, and we're going to put a breakpoint here. I want to stop to see when I get my winnings. All right, so let's pick our own. And what did I say? It was 3359, I think. 3359, I want to say. Yeah, 33. Oh, I'm backwards. Shoot. Okay, I gotta try that again. I need to remember better. Let's try it again. Bugger. Step. Okay, 3395. That's weird. Did it give me the same random? Did it really give me the same random numbers? That's neat. 3395. Okay, let's try it. Let's do a pick our own. 3395. Okay, now we match. So let's step into our function here. We're going to check for a straight win and check for one-off. Let's step into checking for a straight win. If the tickets match, does a 3395 match a 3395? We're going to return 1,000. Boom. Great. So total won should now be 1,000. Look at that. We won $1,000. If only the lotto was so easy to win. Okay, and just for fun, right, because we should always check, I'm going to put my breakpoint here at total won, and I'm going to assume if I just do a quick debug that I'll get different random tickets if I pick random both times. Let's take a peek. So let's just do an easy pick. And we have 6979 and 5756. Those should not be the same. So when we step into our code and we check here, they should not match, and we get $0, right? Perfect. We won $0. So again, you want to be testing both cases, right? The if and the, well, not really an else, but if not if not if, but not if case. Does that make sense? How we're checking both of those here? Super important. Delicious bean juice. Ground bean juice, right? It's filtered water, right? It's just we happen to filter it through ground beans. Dried bean. They're not even really beans, right? They're really like the pit of the coffee fruit or something? Isn't coffee really a fruit and we're just eating the pit or something like that? Really should know. All right, I'm going to Google it now because I'm curious. Coffee, fruit, bean, I don't know. I feel like that's a thing. Yeah, it's the stone fruit of the coffee plant. Coffee cherry, coffee berry. So it's not actually a bean. So bean is a misnomer. That's interesting. Is coffee a bean or a nut? A coffee bean is a seed of the coffea plant and the source for coffee. It's the pit inside the red or purple fruit, often referred to as a cherry. Just like ordinary cherries, coffee fruit also called a... Okay, sorry, that's not what we're here for. Sidebar. Back on track, back on track. So the straight win is the easy one to check for, right? Do they match? Okay. A fun note, if you're using lists here, they'll still compare, right? Coffee doesn't sound as good when you describe it as filtered ground beans. Yeah. Yeah, it's amazing like how your perception affects how much you like something or not. Sorry, my lighting is really terrible now. Maybe I'll try and get one of those real like official lights or something. I don't know. Or maybe I can take this lamp off. Nope, not without taking the bulb out. That's gonna be too hot. Because I've got a nice light here on my desk that usually gives me enough lighting, but it's got a shade on it, so you guys don't mind. You don't have to see my face nice and bright in here. So, all right, for the one-off win, this one was a little harder, and we had a discussion earlier in Discord. Hopefully, you guys are all in the Discord. You fine folks are all in the Discord. Apologize, guys is not really a gendered term. I guess it is. I know very little about this sort of thing, but I should be using folks more often. Because you fine folks instead of you guys. So for the one-off win, it said, let's go back here, right? That 3 numbers match in order, and the 4th is off by 1 for the winning numbers. So I interpreted that to be the first 3 numbers match, and the 4th is wrong, or the second 3 numbers, numbers 2, 3, and 4 match, and the first one is off by 1. If you didn't get that, that's probably okay, because it is a little bit, you know, not super descriptive there, but it does say in order. But there were 2 different ways to match 3 in a row, right? 1, 2, and 3, or 2, 3, and 4. So hopefully you did, and we're going to check for both, right? So we're going to check. We're going to say if winning ticket at 0, right? That's the first item. Less about the meaning, more just what you want. Yeah, I mean, it was ambiguous, so I'm not going to hold anyone to it. Thank you, you did clarify. And that's the right thing to do, but because it's ambiguous, that's my fault for doing a poor job describing it, so I'm not going to penalize anyone who misinterpreted what I wrote poorly. Is that fair? I'm perfectly fine to own up to that it was not described well. But I feel like if I would have said, I don't know, 1, 2, and 3, and 2, 3, and 4, I don't know. Maybe that would have been too much help, or maybe not, because I told you anyway in Discord, so. Anyway, so let's see if they match. So let's see if 0 matches the user ticket of 0, right? And 1 matches 1 and 2 matches 2. Now, we could do that. We could, for sure. We could. We definitely could. And it's not bad. I want to avoid that a little bit, or I feel like I want to avoid it, but it's not going to be worth it, so that's okay. So we'll say if that matches and the next one matches and the next one matches, right? 1 and 2 match 1 and 2, right? So if the first matches the first, second matches the second, third matches the third, always 0 based, right? And now I have an OR case, so I'm going to use some order of operations, right? Because I don't need to even check if they are the same. We only are checking if they're different. So if the third number is the third number of the user's ticket minus 1, that's a one-off. Or, inside this parentheses, here, if it's theirs plus 1. Do you see how we're ORing that one in here? And we need these backslashes to tell Python we're going on to multiple lines. So it usually looks for a single line here. And then we get to that. Oh man, that's the if. We can return, what do we say, $275, I think? Yeah, $275 prize. I'm sure there's some math behind that that tells you whether or not, or why that was that. That's one way, right? And we could also do then, so all of this here, right? Or, let's repeat here. This is messy and I'm not really proud of it here. But, you know, well, that will be okay. So it's 1, 2, and 3 match, right, perfectly. So let me take these out. 1, 2, and 3 match. And 1 is either off by 1 or off by 1. Down by 1 or up by 1. I guess we should add in those spaces there, make that a little cleaner. And then I need to again force some order of operations, make sure this is correct. And then I AND it all together with the other one. Oh, it's okay. Same. It'll be okay. You know, if you're off by 1 there, I won't hold it against you. So that one doesn't need the parenthesis there. So the reason I dislike this is because it's just super awkward, right? Like trying to follow all of this is just like really weird, right? I think I've got extra spaces. Oops, not that. Extra spaces in here. You're like, yeah, now they're all lined up. So on all the cases you missed the one off, or just like one of the cases you missed a one off. Continuation line under indented for visual indent. Under indented? Is it still unhappy with me? Okay, now it's happy with it. So wanted an indented one. Unnecessary backslash. Really? But this one's necessary? That's crazy. Okay, okay, sure. I'll trust PyCharm here. So either we're 1 off on the 4th number, -1 or +1, or we're 1 off on the 1st number, -1, +1, and the other ones match. I don't remember if you guys had asked, but I don't know for sure, so I assumed not, that a 1 off, like a 0, I don't think is a 1 off of 9. Like, I don't think we wrap around the number line like that. So in our case, we're not checking for that. So if we're at 0, we're checking does it equal -1, which it can't, but that's fine. Like, we just don't care at that point. If it turns out it was the case that a 0 should be a 1 off of 9, we'd have to have some additional logic in here, and I would not put that all in here. That just would sound terrible. And I think this is ugly enough, right? I'm not super proud of this, but I think it gets the job done without being too crazy, right? The other option, like just forget this or and just have another if, right? It doesn't have to be all in one if. We could say if it matches here, and then drop this whole other or. If it matches there, return 275. That's perfectly fine too. Whichever way you wanted to go about it was okay. So again, lots of different options for how we do that. And if that didn't happen, then we're going to return a 0. Right? Again, no default, no else, because if you return, your code is done. Otherwise, we get $0 back. And I think that's it. Then, oh, now we need to do the actual total spent. So let's print a little formatted string with total spent and total 1, and a net loss of, that's total 1 minus total spent, right? Now let's give that a shot. I'm going to take out the breakpoint, we're just going to run it. So let's just do a bunch of easy picks. Oops, that was a play again question, sorry. Easy pick, yes. Easy pick, yes. Easy pick. We keep losing money. What's going on? Easy pick, easy pick. We've lost $5 in a row now. Come on. Oops, 1, 1, 1, 1, 1. Play again. Easy pick. No, okay, so I think we're done here. Okay, cool. Glad it's the right one there, Sammy. So I'm actually, I think this is fine for what the project was asked for. So let me commit this so we're not too confused, but then I'm going to go change it for fun and have it just loop a bunch of times just to illustrate the point of how fast we lose. Right, is that fair? Let's do Untitled 1. And we'll do project 0 solution. So it's still in the stub version here, but it's okay. Don't sweat it. Maybe I should have made another one so we could have kept the stub around, but you can look at the history if you want the stub, I guess. Is that okay? All right, so let's not do this play again thing here. Let's just forget that, and we're just going to do this. I will say while total spent is say less than, how about 10,000? Can I put that in there? I feel like I can put that in there. I think I can use underscores in literals. Have we done that yet? And we're just going to do easy pick numbers no matter what. So let's comment all that out and we'll just easy pick. Oh, not user pick. That's right. This one, easy pick. That's the one we want. So let's just easy pick. We'll get our winnings each time. Okay? So let's try it for 10,000 times. See what we get. Look at that! We won some money. We spent a whole bunch, but we won some. Do we start off positive? We started off positive. Oh no, okay. Negative, 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 negative. We're losing money, losing money, losing money. Then we hit a winner. We hit a winner. Look at that. But we didn't quit while we were ahead, so we kept on playing, and we lost. Oh, we got a one-off winner here, right? We went from 400 to 700 something. Is that, sorry, I can zoom that in, make that not an eyesore here. From 400 to 700, so we got a one-off winner. Keep on playing, keep on playing, keep on playing, keep on playing. Should have quit while we were ahead. Should have quit while we were ahead. Now we're losing money. Losing money. We haven't won again yet, out of 10,000 tries. But I guess that's not bad. So out of 10,000, we should have hit one winner. And I don't remember what the odds are for easy pick, but I feel like we should have hit more easy picks than we did. All right, that's a lot to scroll through there. Let's see. Yeah, so we won a little bit. We won $2,100. We lost some. Maybe I'll just list this as profit. And it should be negative, so that should be fine. Let's try it again. Let's do 100,000 runs. See if we can improve our chances. And maybe we should make this prettier, right? Let's add a little $sign, and then we'll do the little formatting string for this, right? Isn't that comma D for digit, right? Is that it? Because we want the comma separator? I think that's what it was. Let's see. Let's try it. That might not be it, but we'll try it. Add some $signs. All right, we'll try it again. Yeah, there we go. Now we get our comma separated. Okay, so we're spent 20,000 or so. We've won 2,000. We won 3,000. Look at that. We won a couple times. 4,000. People win the lottery, folks. People win. Except you lose more often than you win. Go figure. You guys are probably tired of hearing that now. I'm sorry. I just like to complain about it because I think it's an unfair system. Hey, look at that. If you spend $100,000, you can get about 20% of your money back. You guys are sick of hearing about how terrible the lotto is now? We ready to move on? Maybe? I'm going to add a little poll here, so just for fun. So let's, tell expect to get for project 0. So tell me what you expect to get: an E, a D, a C, a B, or an A. Go ahead and vote there in the Twitch poll for me. Go up to the top of chat. Give me a vote for what you think you earned on the project. Right, let's take a peek. I got 8 submissions, so that means 5 people got E's for not turning it in. Is that a correct estimation there? it's not going to tank your grade totally, because it only makes up part of your grade for the class, and the next project is actually worth more, and the project after that will be worth more, and the project after that will be worth more. So it's possible to make up from that deficit. So like don't feel like if you missed it, it's game over. But that should be a big wake-up call that it did not go well if you missed this one. So let me know what you think you got. A, B, C, D, or E on it. Oh, it's a $5,000 prize. I messed that up. I said it was only a $1,000 prize. Why didn't you guys correct me on that? $5,000 prize. Okay, well that changes our math, right? That changes the math. What do we get? So 3 people voted for A. 1 person voted for B. All right, good. I like that. And hopefully having the rubric there, you figured out what it was. Here we go. Look at that, we're doing better now. We lose less money. We're only losing half our money. Okay, so losing half instead of 80% of our money. There we go. I like it. Nice. Okay, so we only lost $37,000 on our $100,000 investment. Right? Take that to the bank. That's got to be amazing, right? Okay, so slightly better in your favor, but still a loss, right? Once we have this corrected. And again, there were other ways to win, so you know, we're overestimating your loss at this point because there were a couple other ways that you could win some money with these crazy games, but I feel like you had to pay more for that if you're doing the box thing. I don't even understand it, and it makes me sad. Just legit makes me sad. So, okay, we'll call this enough. We lost money hard. Okay, so let's just say we added in a loop to lose faster. Yeah, there we go. We're just going to lose faster here. I'll push that one out just for reference. Okay, and push. All right, so that was, oh, did I say Project 2 solution? That was dumb. That's Project 0 solution. I don't know where I got 2 from. That's my mistake. Okay, and again, yours does not have to look like this, right? Functions were totally optional. We just kind of went through, this is what it might look like to break the problem apart. Little bit by little bit by little bit by little bit here. So hopefully that was good. All right, so we're going to finish up functions, and then we're going to talk about the next project. All right, where's our functions here? There we go. Functions. I want to sing that Schoolhouse Rock song with conjunction, function, what's your function? Or conjunction, junction, what's your function? Whatever it is, right? No? Is that a bad idea? I probably shouldn't sing. That's probably a violation of Twitch terms of service, right? If I sing, it's so bad. No? Maybe? All right. Let me pull this up here, make sure we're in the right spot. Functions as objections. I can't type, folks. I can't type. That's functions as objects. As objects here. Now, this is one of the weirder things you can do in Python. Because technically everything in Python is an object. You can pass a function as an argument to another function. It's weird. So let's do a couple here for fun. Let's say define. This is the normal greeting, and with normal greeting, oops, we're going to print hello, and then we'll define a Borg greeting. Any of you fans of Star Trek? Anyone else a nerd? We'll print prepare to be assimilated. If you're the Borg, maybe. Okay, that's all right. And then we're going to have another function called what do we want this one to be? We want this one to be pretend to talk to people. And what you need to give it is the greeting. Now this is where it's weird. So because greeting is the argument you're giving me, if you give me a function I can call greeting like that. And then I'm going to print, what is your name? And then, I don't know, we'll get a name as an input of enter your name, or just right here, we'll just, sure, just an input. And then we'll print, I don't know. No, we just won't do anything with it, so we'll just skip it. We'll just ask what their name is and just ignore them here. So what I can do is I can call pretend to talk to people, and I can give it the normal greeting function, and I don't give it the parentheses, which is crazy. So I just hand it normal greeting. And this is why it's super weird. You can do some fun stuff with this. We get hello, right? Because it printed normal greeting, and then it said, what is your name? So let's do this for fun. Let's do a random one here. So let's import random. And let's say if random.rand int 0 to 1 is a 0, will be normal, else we'll do it the Borg way. Just for fun. We'll give it the Borg greeting. So this is passing a function as an argument. Again, I don't recommend this. It's more confusing than not to me. Hey, look at that. We got the Borg one that time. Let's try it again, because we're just doing it randomly. And we get the regular one. Right? Every other time we should get it. It's awkward. Sure. But it's neat. You can do some fun stuff with it, but a couple common problems you run into is not returning something when you do expect to return something. So a lot of these functions aren't returning anything. Some of them do. So this one returns the area. I think we looked at, yeah, this, if you had result and you print a result, you got this big none. If you don't return something, you're going to get none. So if you get these weird nones in your code, take a look and see if you're returning stuff. Okay, definitely good for looking at there. And then just, it's easy to screw things up. So test your code. Some other particulars to our functions here is when we're using an argument here, like number, and we're changing number, right, we passed it by value. We passed a copy of number here. So we can modify it, but it's not going to be changed in the original. So when we call countdown, it's not going to change this 10 here. Right, so if I were to have like my number is 10, and I'll pass it my number, and then I print my number when we're done, it's not going to change 10 because the function has a copy of number because we've passed it by value here. Right, so we get hello world, countdown, right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off, 10, 20, 19, 18, 17, let's count down from 20, right, so there's our 10 again, because it didn't change. So when we pass variables to functions, for our primitive types, we're passing by value. Later on, we're going to look at, we can pass things by reference, and it gets weird when we pass lists and other objects. So just be careful with that. If you declare variables inside of functions, I don't know if we did that in here, did we? No, we didn't. Did we do it in our other project? If you declare a variable inside the function, it's only accessible inside the function. So each function has its own set of variables that it has access to. Those are local variables because they're defined inside the function. You can have variables that are global. I don't recommend it. It just will cause all sorts of trouble and it's a bad habit. So let's try and avoid global variables. You can look it up in the book, but I will not ask you to use them because I think they're terrible. And I'm sure there's some good reasons to use them here and there, but let's avoid it as a good common practice. So the way Python tracks all that stuff is it uses namespace and scope. So there's a built-in scope, there's a global scope, and there's the local scope. So built-in is all of the stuff in the Python library. Right? Stuff like print is built into Python. Things like using list or int or string or range, those are all built-ins. Global is if we define anything globally. Again, we're going to try and avoid that if we can help it. And then local is stuff inside of individual functions. So number is local to this function here at this point. So when you go to use a variable, it looks, it is trying to resolve the scope. So it goes from local to global to built-in when it tries to resolve those things. So it goes from smaller to bigger as it's going to resolve them. A lot of times it just means be careful with what you name things, because they might do some funny things. But that should be fine. Right, so we've done function arguments, passing, pass by value, pass by assignment. The book calls it here, so we're making a copy of those here. If you are passing something by reference, so that's not getting a copy, then if an object is immutable, like a string, then you can't change it. And I know this is going to sound a little funny. We'll do some examples in a minute. But if the object is mutable, then you can change it. So let's look at a couple more here. Let's actually start up a new project because we don't need all this junk here. So let's do chapter 6, more functions. And this is an important distinction here. So let's make, say, let's make a function that is going to, we'll say, remove odds given some list. So if you give me some list of numbers, I'm going to remove the odds from it. Okay? To do that, right, we want to say for, well, we don't want to do it that way, actually. Remember, if you're looping through a list, like for number in some list, we can't actually change number, and we can't change some list. Bad things will happen here. So what we need to do is we need to loop through a copy of the list. We haven't got to that yet. Shoot. Okay. That's not going to work very well. Let's just do double odds. Okay. So if a number is odd, we want to double it. So again, if we're using that loop, like for number in some list, if I say number times equals 2, it's not going to change the value inside of list, right? Because we're getting copies out. So what we need to do, we need to say for index in range, length of the list, some list. Does that ring any bells? Now I can use the index value to go through that list. And I can say if some list at index mod 2 is 1, because that will tell me it's odd, right? If you modulus 2, divide out all the 2's. If you have a remainder, you're an odd number. Then I'm going to take some list at index times equal 2. I can change the value at that index. Right? So let's just ask a user. We'll say, I don't know, we'll make a numbers is a list, and we'll say while the length of numbers is less than 5, we'll get numbers.append an int of an input, enter a number. Okay, so we should add 5 numbers, right? The length of numbers is going to be 0 to start, so this will be true. It's going to run less than 5. Why is that unhappy with me? Expect, length. There we go. There we go. Yes, we need to do that properly. Length of numbers less than 5. Let's go add a number. And then we're going to print out numbers. Then I'm going to hand the numbers to my double odds function, given the numbers. And then we'll print numbers again. Remember, lists are mutable. You can change them. So when we pass it here, let's give it a shot. Let's, I don't know, 1, 2, 3, 4, 5. We get 1, 2, 3, 4, 5. When double happens, all the odds get doubled. So now we have 2, 2, 6, 4, 10. That's what we'd expect. Sorry, let me zoom that in for you here. That's what we'd expect. We're able to change the list because we passed the list here. So when you pass a list, you're not passing it by value. We're passing the location of the list. We're passing the reference to the list. I know some of the terminology is going to be a little awkward, but when you pass a list, you're giving them access to the list itself. You can append to it, you can subtract from it, you can change things inside of it, all that good stuff. So you have to be careful with lists because they're mutable. So we can change it in there. And the book has some other practicing here. Oh, good. It does show you the copy thing. Okay. So if you want them to not change your list, what you can do is you can use this cool slice notation. And what this means is give them a copy of my list from the beginning to the end. Once we get to lists, we'll play a lot more with slicing. But for now, you just square bracket. So list at everything. It's crazy notation, but this is a copy of the list. So now when that happens, 1, 2, 3, 4, 5, my list won't change because I gave them a copy of the list instead of my original. So that's how you can protect your lists if you want. You've got choices there. We okay with that? Maybe? Okay. Some other cool stuff you can do with functions is you could have default arguments, which is really cool. So I like the default here. So we're going to write a function for print date, and we're going to take a month and a day and a year, and we're going to print, and I'm going to print it my format, the way I prefer, the formatted string, an F string, is year-month-day, because this is the ISO standard, and it sorts nicely, is why I like it, because it will sort ascendingly, just by using an alpha sort. If you do the stupid English way that we do it, which is month/day/year, you get all of the months, regardless of the year, sorted, and it's stupid. I don't know why we have that format. I guess because we say, like, hey, it is October 8th, 2020. We don't say it's 2020 October 8th. So maybe we're more modeled off of how we talk. But again, it's just dumb. So, but what we can do is, if most of the time we know what the year is, we can give here a default value inside the function. We can say year is 2020. So if you don't give me the year, I'll just assume it's 2020. So I can call print date, and I can give it 10/8/2020, or I can call print date, and I can give it 10/8, and it will assume the year, if you don't provide it, is 2020. There, another space. Okay, so let's give that a shot. Enter some numbers. Okay, and it gives me the same format, because it's a default argument. These things are fantastic. Now, if you get confused about what is what, because remember, arguments are passed in order, right? This is the positional argument, is the technical term for it. So the first position is the first argument, the second position is the second argument. You can use this really cool syntax called keyword arguments, and you can say month equals, and you can say day equals, to be explicit around which argument matches which parameter. And if you do it this way, you can do them out of order. Sure, I mean, I don't really care at that point. But that's a really cool feature you can do. So the date formatting, yep, lists. You don't want to have lists as defaults, because bad stuff happens, and that's as much as you need to know. So don't use a list as a default argument. The book has the right way to do it. You can go read that later. I won't ask you to do it. Just know it's a big no-no. So there's better ways to do it. Arguments and defaults. Yep. This arbitrary arguments list is neat. You can read about it in the book. Again, it's not something I'm going to ask you to do. Once we've done some more work, and like once we get into like plotting and stuff, it might make a little bit more sense. But again, we're just going to skip it for now. Function outputs. Remember, a function can only return a single thing. But remember, what the trick that we did in our project is you can return a single tuple. So if you just have multiple things to return, Python will turn it into a tuple for you, which is really cool. And the technical term for that is packing and unpacking. Okay. Help strings, that's fine. I trust you can learn how to use comments. Super helpful and all, but that's fine. Right, so that's the end of functions. We're going to practice them in lab on Monday. And again, I mentioned on Tuesday, I'll post it in Canvas. No one came on Monday. Maybe that was my fault, but I mean, we've only had like 3 people ever come. So I think we're just going to move labs to fully virtual, and I'll just hang out on Discord during the lab time or Zoom, whatever works best for you guys, and we can hop on and do screen shares, and we can go from there. Because I think now that you've got set up and you got up and running and you can write some Python code, there's not a whole lot of benefit of us standing 6 feet apart and staring at your screen like, I can kind of see it. So we'll just move to fully virtual labs every Monday. And I'll post that in Canvas as a reminder. So we'll have a lab to practice functions on Monday. You can do a bunch of stuff. And let's talk about the next project that's coming out. So project 1, I just have to hit this publish button. Look at that, I'm actually prepared this time, although I don't have your quiz ready yet. Yeah, all the other quizzes are out there. Those ones are coming up due. Quiz 4 and 5, don't forget. Project 1, let me hit publish. All right, so you should be able to see project 1 due next week, or two weeks. All right, so you get 2 weeks on this one. We're going to build a little hangman game. So hangman, you get 6 guesses until you lose, and each time you print your hanging man on the gallows. We're doing this all inside a function, so every operation here is a function, and I'll show you that down in the rubric in a minute. So we're going to use a function that takes the number of body parts to display. So if you display 0 body parts, you have an empty gallows. We're just doing some little ASCII art. There's no guy here. 1 body part is the head, 2 body parts is the head and the body, 3 body parts, either pick an arm or a leg, I don't care which one, 4, add 2 arms or legs, 5, 3 arms or legs, 6, they're hung and game over. So 6, and I'm sorry, that's 6 incorrect guesses until they lose. I should, 6 incorrect guesses. I should be more specific there, I'm sorry. 6, come on, load. Load for me. 6 incorrect guesses until they lose. Projects, submitting a URL, good. All right. So here's a little thing. So you're going to use a random word from this word list I gave you. I picked like 1,000 common English words or something like that. And you display blanks for every letter in the word. Right? You allow the users to guess a letter in a function. So we have a function for guess a letter. If that letter's in the word, you replace the blanks in another function. If it's not, you add a body part to the hanging man. You keep a list of the already guessed letters and tell them if they try to guess that letter and have them guess again. So that you can't re-guess a letter and have it count against you. We just discard that one and say you can't guess, you can't repeat. And then at the end, either win or loss, ask if they want to play again. So you can copy in this word list here, right, into one of your places here. I don't know, I'll just throw it in here. Why not? It's really big and long. It's going to yell at you, but don't worry about it. That's fine. So we have a way of getting a random word out of here. Did you know that? Yeah, I guess we should fix those spaces. Right? Because I can find the length of the word list. Right? Is how many possible words are in here. I can pick a random randint from 0 to length -1, because remember the length is how many words are in there. Oh, I didn't import random. Shoot. That's in a different project. We're going to import random. So from 0 to the length of the word list -1, because remember, what we want to do is we want to get values out by index. So this is the random index is from 0 up to the length -1, because random is inclusive because it's crazy. Right, and then I can get word list at, so let's print word list at the random index. Right, so you should be able to get a random number out every time. So now we got might. That's our random word this time. Let's try it again. See if we get a different random word. Now we got expert. That's a different random word, right? So pick a random word out, use that here in your hangman. So let's take a look. We have got the rubric. So 6 incorrect guesses until you lose. You get a point for that. You get 4 points for having a function that prints the gallows and the hanging man. Right? You get 4 points for having a function that allows the user to guess a letter. So that function should return the letter that they're guessing. Right? Or something inside of that, right? It's part of the guessing function. And depending on how you break it up, I'm not too particular one way or the other, but like guessing a letter should happen inside of a function call. Don't allow the user to repeat a letter they already guessed for 1 point. A function to replace blanks with the guessed letter, 4 points for that. So if you know what the letter that you guessed is, and you need to replace those blanks, right, you're going to get 4 points for that inside of a function. And then letting them play again, yes or no, 1 point there. Okay? So if we're doing stuff inside a function, you're going to need to pay attention to scope. Right? Where are your variables declared, and are you passing values that are mutable, or do you need to return values? Totally up to you. There's lots of different ways to go about it. Some are more efficient than the other, but at this point, it's a stupid hangman game. No one cares. Right? You can learn all about efficiency later on. We'll talk about it next semester in 2001. You'll talk about it in 350, your Algorithms, Analysis, and Design class, and it'll be much more important. For now, we're just learning how to code. Right? So we're going to say efficiency doesn't matter for now, which maybe is setting up for bad habits, but what we care about is learning to code. So I figure you can learn that stuff later. Right, so this one's worth 15 total points. The first project, Project 0 there, was worth 0. I'm sorry, was worth 10 points. This one's worth 15. So the next project is probably going to be worth 20. The project after that, probably about 25. And that'll be your 4 individual projects. So 10 plus 15 is 25, plus 25 is 50, plus 20. You'll have 70 total project points over those 4 projects. Right, so if you didn't do so hot on Project 0, that's okay. That's only a seventh of your total project score there. Okay, so just make sure you double down, work on this. If you have questions, if it's just like a conceptual question or a clarification, please ask it in the Discord so the rest of the class gets the benefit of what your question was and what the answer was. Because if you're not sure about it, I can guarantee someone else is not sure about it either, and that'll save me from having to answer 2 or 3 different emails. If it's, hey, something in my code isn't working, don't copy paste your code in for me. Take that to a direct message and shoot me a link to your stuff in GitHub, and we can go from there. Does that make sense? So this is more methods. Commit and push that one. And this is my second pot of coffee for the day. I'm feeling a little hyper at the moment. You guys doing all right? Clear, not clear, fuzzy, solid, terrified of the next project, feel like it's going to be okay. Again, it's really difficult for me because I don't see you and can't see the looks on your faces to know how it's going. But I don't know, I'm still opposed to having a Zoom thing and telling everyone, keep your webcams on and that sort of thing. Just sounds terrible too. So I don't need to invade your privacy of wherever you're learning from. So I think I'm still pretty solid on using Twitch, and I think it's working well. And we can do meetings face-to-face. We can do video calls on Discord. We can do video calls on Zoom if you want, and I'm happy to do that. Just ask. But I think this as a lecture format seems to work out well. Yeah. So, by the way, I'm not dumb. I know you can Google a Python hangman game, right? Don't, I know it's out there, but what I'm asking you to do is do it in this particular way where we're designing it with these functions. So go through that process, right? Try and do this functional decomposition. What's my big problem? How do I break it apart into smaller and smaller and smaller pieces? And I tried to give you a little help here, like, hey, have a function that does this. That's one problem to solve. Have a function that does that. That's another problem to solve. Have a function that does that. That's another problem to solve. Right? This guess a letter and don't repeat probably happens inside the guess a letter. It doesn't have to, but it could. I mean, you can put it either way, either before you return the letter or after you return the letter. Totally up to you. So that's the art part, I like that, of programming. Right? We're just going to design it away. So take the time, write out the stub like we did for Project 0 when we were practicing functions. Like this function gets called, and then this function gets called, and this function gets called. They don't have to do anything yet, but take some time and do that. I'm fond of that. Another super useful technique is Pseudo Code. I think we've talked about it before, where you're kind of solving the problem in English and you're just writing down step by step by step by step. That's a really good habit to get into, and it's something still done by professionals. Right? A lot of times as we're designing solutions, we whiteboard it. So at the office, at my work, not that we go in person anymore, but we used whiteboard paint on all the walls. So on any given wall in the office, you can just kind of start scribbling on the whiteboard to be showing something to someone else as you're talking through the problem. Like, okay, here's the problem we're trying to solve. Here's what I think, and this piece will talk to this piece, and then we'll call this thing, and we'll do it like that. Yeah, it's super useful because the part that's hard of programming is problem solving. It's breaking the problem down step by step by step. And I know that might not sound true because the syntax is also hard when you're learning it, because like you have colons and you have tabs and you have ifs, and you have all these techniques. But if you can get it solved in English, translating it from English to code is going to be way easier than just jumping right into code and trying to make something work. And it's just going to come out so much better for you. Again, you guys are welcome to talk to each other. You're welcome to ask questions in the Discord. You want to keep that at a conceptual level. The moment you're starting to like take notes and write down code, you've gone too far. So again, you're welcome to chat, discuss it like, hey, I might do this, I might do this, I might do this, might break it down this way. Perfectly fine, right? Like saying what the names of your methods are or your functions are, that's great. You know, you guys can work together, collaborate on that sort of thing. But you're not giving the code of what that function does, right? That's too much there, and then we're just cheating off of each other. So yeah, so feel free to discuss it. I mean, I'd like when we're in person and we have a few minutes to kind of talk about some approaches. Definitely encourage that. It's a great thing to do for labs as well. For the labs themselves, you guys are welcome to work together. As long as you're each writing the own code, I'm okay with that. Like, don't direct message someone else the code and they copy paste it in. But like at the lab assignment level, you guys are welcome to collaborate as closely as you want, as long as you're each typing your own. That's okay, because the labs are practice. It's not high stakes for the labs at all. The projects are where I want to see, can you do it yourself, at least for this translation part. And you know, the problem solving is hard, and sometimes it takes more than one person. And I do hope later on in your careers you have that chance to work with other people, because it's really lonely working all by yourself and never talking to other people. You're like, here's my project, I'm heads down on my project over day after day after day after day. No one talks to me, I don't interact with anyone until I have something that's done. That's really boring. It's much more interesting to work with someone else and bounce ideas off of people, and you do get a better product out of it as well, because two heads are better than one. All right, well, that's all I got for you guys. You got a couple extra minutes to get whatever you need, start on the next project, or just take it easy. It's 5 minutes, sorry, I guess it's not very much. Make sure I got all this out here. New line, I'll commit and push that. And then Monday is virtual lab, so I'll be hanging out in the Discord. I'll post the lab assignment, you guys can work on it. Again, try not to get behind on those. It's just going to pile up more and more headache for you. It is a 4-credit college course with a lab, and typically labs take more time. So like it's technically 3 credits of lecture, 2 credits of lab, but you pay for 4 credits and you get 4 credits. I don't know how that actually works. But with that sort of math there, if it's a 5 credits worth of effort, you're doing 10 hours a week of homework just for this class, between the readings and the labs, and not even the in-person lab time. That's out of lab time, right? The outside of the lab meetings time. Hopefully all the labs you can get done in an hour 45. That's not always the case. Sometimes it takes a little longer, but that's sort of the goal there. They shouldn't be huge, but sometimes you got to puzzle over it for a little while. So, all right, it's been fun. I'll catch you guys Monday on Discord, not in person. I'll post it again in Canvas, and then Tuesday we'll be back for live stream 3:30. I'll see you guys then.